Okay, so 1 over x is like the parent function, and I'm just going to go ahead and draw it so that you can see it, and so that you have it. This is like the original, so if you're ever trying to figure out what it looks like, that's the original. And like it's very positive up there and then comes down here to the negative. And then as I showed you in the interactive thing, the A is a stretch. And what it does is it just moves these two pieces away from the center a little bit. But it just sort of stretches it. H, if H is positive, it moves to the left. If H is negative, it moves to the right. So it's opposite of what you think should happen there. And I've got a minus K, but it really doesn't matter if it's a minus or a plus. If K is positive, it moves up. If K is negative, it moves down. So H is moving it left and right, and K is moving it up and down, depending on if it's positive or negative. And so we're going to talk about some transformations using this form, although it might be written in a different form as well. And we might have to look at Desmos to graph it, or we might can just figure it out without having to do that. So, on the first one, I realized that on the bottom, that's where the number is. I know it's down here on the bottom, x plus 2. I know that 2 has to do with h. H is positive, so which way is this moving it? This would be left 2. Now, if you're not sure, you can always just graph it in Desmos 1 over x plus 2. It's just kind of hard sometimes to tell exactly where it moved, okay? So originally, the line going up and down, it was at 0, and now the line going up and down is somewhere around here. Yeah, it looks like it's around 2, so that looks like it moved it left 2. So either you have to use the pattern I just showed you, or you have to graph it and kind of look at it. And the graph sometimes is hard to tell. Alright, so this one right here, 1 over x minus 3. The minus 3 is the k. The k is negative, so this is moving it down 3. Again, if you want to graph it, you can. 1 over x minus 3. And it's hard to tell, again, exactly how much. Originally, our line going across was at 0. And if we just count and kind of go in the middle of these two, it looks like it's around 3. There's not a good way to tell where that would be. Now, if you wanted to check it, you could put y equals 3 right there. Or negative 3, sorry, because we moved down. And as long as that was like in the middle of it, yeah, that would be right that I moved it down 3. If you wanted to draw that, you could just to see it. That's up to you. Alright, so number 3. This is underneath, so that has to do with the h. It's opposite, so this would be moving it right 1. And then the plus 2 is out here where the k is. K is positive, so it's moving it up 2. Again, we can graph it if we wanted to check. Be careful when you're graphing. Make sure that if it's on the bottom of the fraction, that it's completely on the bottom. Again, it's just hard to tell, but you can figure it out. If you can look and see how much it moves right and left and up and down from there. Alright, number 4. Alright, on the bottom, that's the h part. And so that's going to be moving it left because it's opposite, so left 1. The 2 on the top is a stretch. And I didn't tell you what would happen with that negative, but that negative makes it be a flip. The negative makes it, instead of coming over these 2 quadrants, it's going to flip it over this way. Okay, so if I graph that one, see it flipped, and then trying to figure out where that line is and where that line is, it might just be a little bit confusing. If you can do it with the graph, do it with the graph. But if you can't, you might need to look at the pattern that we have written up here to figure it out. Okay? So, again, the 3 is a stretch. The negative is a flip. Alright, the 4 is out here on the outside of the K. It's a positive 4. If K is positive, it's moving up, so this is up 4. Alright, the last one is not written the same way. So on the last one, we really do have to graph it and sort of figure it out. Okay? So I'm going to do 3x plus 7 divided by, notice how when I put it in Desmos, if you put divided by, it only does 7 divided by. So what you're going to have to do to make it work is you're going to have to put a parentheses around what's on top and then divided by, sorry. When you do divided by, it'll put it all on top so that it's written correctly. If you don't do it that way, you won't be able to get it all correctly written. That 7 would be different. Alright, so on this one you really do have to graph it to figure out what's going on. Alright, originally our point, or the center, would have been at 0, 0, so it looks like our center's moved up here somewhere. So it looks like it moved this way, -2, so left 2. And then it looks like it also moved up 3. So left 2, up 3. And also what happened is there's a stretch. The stretch is not obvious to us by looking at it. The left 2 and the up 3 are really, really important. But the stretch, if you don't realize the stretch, it's probably okay. The way to tell that there's a stretch is there's a number in front of that x. And so usually that will help you figure out maybe if there's a stretch or not. But again, it's kind of hard to tell if that happened. But we're going to go ahead and say that it happened because we think that it probably did. So for all of them, the domain is all reals except where the bottom is 0. So when I look at A, where would the bottom be equal to 0? What value could you plug in for x that you would get 0? Well, it would be 1. And if you didn't know how to just look at it and tell, you would take the bottom, set it equal to 0, and solve. Like you could say x minus 1 equals 0, add 1 on both sides, you get x equals 1. So the domain is everything except x equals 1. And you could say all reals except x equals 1. Another way that you could say that is x does not equal 1. You could say it either way. Alright, so looking at this one, we're setting the bottom equal to 0 again. We still get 1. So this one's all reals except x equals 1. C is exactly the same again. They won't all be like this. All reals except x equals 1. Okay? Thankfully, D is something different. So we set the bottom equal to 0. We figure out what value it can't be. The value it can't be on D is -1. So this is all reals except x equals -1. Because it's the opposite of that. And that's the value when you plug it in, you would get 0. Okay, E. This one would be all reals except where the bottom is equal to 0, that would be x equals -2. And then again on F, all reals except x equals -2. Now, I can use what I just figured out to figure out some of these graphs. For example, this one is the one that's different from all the rest because it says x doesn't equal -1. So if you look at these and go to x equals -1, the only one that has that little dotted line at -1 is A. So I know that this one is A. And I'm just showing you so you don't have to graph them all in Desmos. Both of these are x equals 1. And this one. So these three right here, I know those are A, B, and C in some way. These are the x equals -2 ones, because they have that little line there at -2. The only difference in these two is this one has a positive and this one has a negative. The positive ones are going to be this way. So this one is going to be D. And then the negative one goes this way, so this one is going to be F. So I know that we're down to these three. And those three have really slight differences, and you may have to just graph